Our last example is to find the area of the common interior of these two shapes. So I have r equals 3 cosine theta and r equals 1 plus cosine theta. So again, I'm going to graph these and then we'll take a look at what we're dealing with here with the common interiors. R equals 3 cosine theta is going to be a circle with a diameter of 3. It's going to be to the right of the y-axis, and it's going to have x-axis symmetry because we're dealing with that cosine there. So I have a circle there. And then my r equals 1 plus cosine of theta, I'm going to have, here I'm going to have a cardioid because I have the coefficients are the same and the absolute values are the same. The 1 here and the 1 cosine theta. So I'm going to go here. So this one is going to look something like that. Alright, so I'm gonna I won't label them, we'll just keep in mind what the circle here is 3 cosine theta and the cardioid itself is the 1 plus cosine theta. So when I'm talking about the common interior, I'm really talking about this area right here is what I'm looking to find there. Alright, so that's what I'm trying to find. I know that the angular measurement right here is theta equals 0. And I know that right up here is theta equals pi over 2. And so what I'd like to find is, I'd like to find where those two intersect one another. All right. So if I integrate from theta equals 0 to this theta measurement, it's going to give me this area right here, which you can see is just the area inside that cardioid. All right. So we got to find this value right here. I have to find that angular measurement, and to do that I am going to set the two radius or radii equal to each other. So I have 3 cosine theta equals 1 plus cosine theta, and so that means that 2 cosine theta equals 1. That means I'm looking for where the cosine of the angle equals a half, and we know that that happens at pi over 3. Right. So I can find this darkly shaded area if I integrate from 0 to pi over 3 and find that. But you'll notice here that I have a very small sliver, and it's kind of hard to see in my drawing because it's not very good, but you can see that I have a very small sliver right here, very small sliver of that circle that is not included when I integrate from 0 to pi over 3. But it is part of the common interior of these two shapes. Alright, so we're going to have to account for that also. So in order to get that little part of the shape, I have to go from pi over 3 to pi over 2 and use the area that is inside of the circle. You can see that that sliver, that little sliver of circle is what we're missing here. And so I'm going to have to integrate from pi over 3 to pi over 2 to get that little sliver that I'm missing when I go just from 0 to pi over 3 inside the cardioid. So I'm going to zoom out here a little bit so we can see the work. So when I calculate, I'm going to go 1/2, and then I'm going to integrate from 0 to pi over 3. And that's going to be the quantity 1 plus cosine theta squared d theta. And again, this gives me the common interior that is contained inside that cardioid between 0 and the angular measurement pi over 3. Alright, so that gives me that one. But in order to account for the total common area here, I have to account for that sliver of the circle. So I also have to integrate from pi over 3 to pi over 2, this time my integrand is going to be 3 cosine theta. So I have the quantity 3 cosine theta squared d theta. And so this quantity right here is going to give me the entire top half of the common interior. So it's going to give me this shape that I shaded in here. It's going to give me the sliver of the circle there. So in order to find the total common interior, I'm going to have to double that quantity that I find there. And when we work through these two integrals and then double them, we're going to find that the area is equal to 5 pi over 4.